This is a rough tutorial on how to conduct or how to go about passive element circuit analysis. The way these problems are virtually always given is that there's a big blob representing the rest of the circuit that is not important and does not need to be considered, and the element under analysis, which is represented by a box. Now the way this works is there's two steps. First off, an initial assumption based on how the direction of the current through the element relates to the potential drop across it, and then just calculating a power using pi. Power is the product of current and potential, and then combining that with the initial assumption, determining whether or not what the sign of the power is. And in this method of analysis, the power is going to have a positive sign if the element is a load, a negative sign if the element is a source or a supply or whatever. Same thing, pretty much. In the case of this first example problem here, looking at the direction of the current through the element, the current experiences a potential drop as it goes through the element, so therefore we are going to assume that the element is a load. Then, again, just take the product of the potential and current. 4 volts times 4 amperes is 16 watts. Because our initial assumption is positive and everything else is positive, the result is positive. Therefore, we can say that this element is a load. The next example problem down here is that the direction of the current going through the element, it experiences, again, the signs could be either way. That's again, don't fiddle with this, don't change any errors or anything. It will cause you to get the problem wrong because it's introducing an error. This, looking at it again, the current as it goes through the element, it goes from a relative positive to a relative negative, so again we can assume that the object is a load. Now, again, take the product of the potential and the current, negative 3 amperes, and it is negative 15 watts, so this is a source. Now, next example. Again, same thing. Looking at the element, looking at the direction of the current, it goes from a relative negative to a relative positive. So we can assume, or we make an initial assumption, that the object is a source. And so what we do is, in the power calculating equation, we put a negative sign out front, and then the other, power calculation is done in the parentheses, and then multiply the negative 3 volts times 2 amperes, and you get negative 6 watts, but this negative sign out front from the initial assumption negates that, and it's positive 6 watts, so this is a load. Now, next example, same direction of the current is, it goes from a relative positive to a relative negative, so assume that that is a load. So again, positive, which in this case is just represented by nothing in the power equation. Then multiply negative 7 volts times negative 1 ampere, 7 watts, because again the two negatives cancel out. And one last example, done in blue just so that it doesn't get confused with the other stuff on this board. Current goes from a relative negative to a relative positive, so assume that it is a source, and then multiply negative 2 volts, negative 7 amperes, so the negative 2 volts, negative 7 amperes, cancel, the negatives cancel out, so that's 14 watts. But because of the initial assumption, we need to make the result of that negative, so 14 watts. Again, nothing, so this last element is a source. Again, nothing really super fancy, super booga complicated, because this is still the nice, simple, easy stuff. Yeah, when it gets to involve calculus, that's going to be really fun. Yeah.